Alright guys, actually nobody's here yet. Okay, but I'm doing part 2. Just now I had to go eat dinner, so I had to stop it for a while. So okay, anyway, I'm continuing this integral. The integral of secant of 7 is secant to the power of 7 of x. This, okay, anyway, this is a standard integral that you can do, and this standard integral would be equal to the natural log of the absolute value of secant of x plus tangent of x. Yep, and from there, that's just the answer plus c. I'm not going to simplify this though. It's kind of a bit of a thing to simplify. If you want to simplify, you can simplify it yourself, because it's a very complicated answer. I'm gonna vomit. But okay. But anyway, let's do the next request. Wait a second. Yeah, so this, okay. Okay, so anyway, the next request. The next request is a big boy, which, okay, I will tell you what it is. It's from the greatest challenge yet that I posted, and it was the triple integral. And then, okay, hello person who is here. I'm not sure who's here though. Okay. But anyway, there was this person who asked. Okay, I forgot the plus c that time. And then he said, for fun, I should check my answer. And don't forget, this was the triple product integral. Over here. Alright, that person left. So I'm gonna check the answer to this by differentiation, which is probably not gonna be that easy. So first we need the answer itself first. So I'm just gonna, yep. So really, this is just going to be asking for the derivative of x e to the x sine of x minus e to the x, minus x e to the x cosine of x plus e to the x cosine of x all over 2. Yep, and this was requested by, forgot who? Pete Sounds. There. Alright, so from here, to differentiate this, we would need the product rule. Okay, so this, okay, we use the product rule for this. I would do, okay, first the derivative, first one. Wait, I'll find the derivative of the first x, which is 1, Then we get e to the x sine of x. Then we add x multiplied by whatever it is, which is this, which would be equal to first we multiply by e to the x. Okay. First we multiply by the derivative of e to the x, which is e to the x. Then sine of x. Then we add the derivative of sine of x. Then we add e to the x, which is e to the x cosine of x. And wait a moment, I'm gonna go. Wait a moment.
Thank you, Amy.
Alright. Hello. Okay. So continuing this. This would just be for this first part only. Oh my god, and actually you can see something here. Anyway, from here, e to the x sine of x plus x blah 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 blah. Expanding it would give x e to the x sine of x plus x e to the x cosine of x. So that's the derivative from the first part only. It's very hard to do actually. Let me think. Yep. So that means from there now, okay, I'm just gonna put this somewhere. From there, we subtract the derivative of this, which would be, firstly, we get First we find the derivative of the first one, and then we get e to the x cosine of x. Yep. And then from there, all we have to do is just add to the derivative of this. Okay, we add x, then we multiply all by the derivative of this. That would be e to the x cosine of x plus e to the x, minus e to the x sine of x. So from there, it would be x e to the x cosine of x minus x e to the x sine of x. So we erase these brackets, and then this one will become minus, this one will become plus. Let's see if we can cancel anything yet. Well, so far, there is something we can, there is x e to the x cosine of x and negative x e to the x cosine of x. So we can cancel those out. So we take this, subtract e to the x cosine of x. Then we add x e to the x sine of x, which gives us 2e to the x sine of x. And then from here, all we can do is just find the derivative of this. The derivative of this, So house equals to e to the x sine of x plus e to the x cosine of x. Yep, that's definitely it. Yep, correct. And guess what? You can cancel this and this. So we get 3. E to sine x. And then from there, all we have to do is divide by 2. Well, we've got a problem here. And okay, we've got a problem. It's too hard to do it, but okay. But I'll use a derivative calculator though, because my head really hurts after doing all of those requests. So my head hurts. Look at that boy. Look at that big boy. Yes. Okay, so apparently it's correct. And it's very hard to do so far. It's very, very, very hard to simplify it. But apparently we get the right answer though. Okay, so anyway, we're on to the next request. And ooh, this is the last one. It's the last one. This one doesn't make sense though, because it's an inverse function. It's to find the inverse of a function, but it's not really possible to find the inverse of that function. And he asked, what is the inverse of x, ln x? There isn't an actual inverse, but I will write it down explicitly. So first I'll write inverse of x multiplied by the natural log of x by some person called
Ahmad Salama.
Ahmad
Salama.
Quiet lah.
What?
I know. Requested by this guy. So actually we can't find the inverse itself, because it required the Lambert function w of x.
What?
But well, there is the method. It's equals to x, natural log of x. So then from there, we have to raise everything to the power of e. So then it's e to the y is equals to e to the x, natural log of x. And what's that equal to? That's equal to e to the natural, okay. E to the natural log of x, all to the power of x, which is equals to x dx. So x to the x is equals to e to the y, but we can't really define it explicitly. So therefore the only thing we can do, well, I mean, there isn't anything that we can do to find the inverse of x ln x. Well, there still is a way to find it using the Lambert function, but it's not easy. Using the Lambert function, it's not gonna be easy actually. Oh, sorry, it's a Lambert W function, not a Lambert. But it's Lambert W function. Okay. So defining it implicitly, we get x to the x is equals to e to the y. But let's say we wanted to define it using the Lambert W function. Then we have to do another way. We have to do y is equals to x, natural log of x. That's equal to y. So that means the natural log of x is equals to y divided by x. From there we have to change it. Negative natural log of 1 over x. This is still this. It's equals to y multiplied by 1 over x. Then from here we have to do something. We are going to set an a. No, let's set it to u, okay? U is equals to 1 over x. Then we get negative natural log of u is equals to uy. And from there we can actually change it. Yep, negative natural log of u. Then we get negative natural log. Negative natural log of uy minus the natural log of y the negative of all of that, I mean. That is equals to uy. Then we get natural log. And then we just simplify that to get the natural log of y minus natural log of uy is equals to uy. Then actually, all we have to do now, we can set z is equals to ui. Setting z equals to ui, we get z is z. We get z is equal z plus natural log of z plus natural log of z is equals to natural log of y. Thus giving us z e to the z, erasing each thing to the power of e. Z e to the z is equals to y. Then using the Lambert function, we get z is equals to w of y. After all of those steps, we get z is equals to Lambert function of y. Thus giving us u is equals to z over y. Is it? Yep, u equals z over y, which equals to Lambert w of y over y. Then we get x is equals to 1 over u, which is equals to y over w of y. So therefore the inverse of this is equals to x is equals to the Lambert w, equals to y over the Lambert w function of y. Wow, that was such a tough thing. But, okay, you get it. So, that's the inverse. Alright. Oh my god, what happened here? There's something wrong with the camera. Alright, so thanks for watching. So I hope you will subscribe. And thank you. And see you next time. Bye.